So can you calculate the following one? You have a long get that? So look at this problem. You have a long way of explanation, right? But when you solve it, do not be thrown off by so many languages and values and temperature and molecular formula. You just look at what you need and what you need to calculate. So you need to calculate for this problem, what is the energy, right? Calculate energy, and what do you have? You have the wavelength, and you know the C, you know the H. Please solve it.
Is that supposed to be 4.50
Yes, 4.5 times.
So it's not supposed to be nanometers in the second part? Okay. This isn't that the total.
The same thing.
Oh,
Because 4.450 is the same thing.
but it's still nanometers.
So nanometer and nanometer, yes. Because only two. What happened? Here the two decimal changes.
It's the same number. But it's,
Please solve
well,
it.
that's not converted.
Even though it's easy, guys, from my experience, I'm saying that the easy thing people forget more. They think, oh, it's very easy, I can do that. When it comes to the exam, you forgot to calculate the nanometer to meter. You forgot to calculate time to second. Then you do mistake. Anyone can do on the board? Yeah, take it off. So what we got? 4.42 10 to the 19. Yes, it is. So that's going to be, and cancel out second per second, meter, you get in joule. So I have one more problem in here. Please solve it by your own. I'll be posting PowerPoint. This is still going to be modified PowerPoint. I'll be posting it for you, okay? And any question, please shoot me email and let me know. We'll solve it next class. And next part is board model, right? Board models, we talked about that in chapter 1, chapter 2 actually, by the way. But we'll be talking in details about in this chapter, but not the other theories that we taught. So board model, what is a board model? Can you remember any postulates?
Used to show
Board models, yes.
electrons jumping back and forth.
Yes, very key thing you said. Even that's not the first one, but the very key thing. Electrons jump from the back and forth. I describe board model like a building. You know, it's easy for you to remember. Like you have a building, right? Multi-story building, right? Atoms are like that actually. Bohr said that atoms are like multi-story building. Okay? In the whole building have different stories, right? And if you go up, energy going up, because you know the potential energy. If you go up, potential energy goes up, right? So same way, building structure is similar to electron in atom. So first thing he said, compared to the building, okay, let's go all the properties in a building, okay? First thing is building has a different storage, no? Different stores, different levels. Second thing is each level have different specific level of energy, isn't it? And each level has each level. If you go to up, energy going up, because you know that based on the potential energy going up. If you, for example, if I jump from the, if I jump from the second floor, I'll get hurt, right? What if I have multi-story, 10-story building, and I jump from the 10th floor?
You're dead.
I'm dead? Oh. Which is true, right? You know that many story people did not die, even they jump from the 10th-story building? That happened over there. It happened, yeah. Anyway, so if you jump from the upper floor, then the lower floor, you'll get more hurt, right? Because you're jumping with the upstairs, downstairs. Or otherwise, let's go to the atom. Let's take the analogy to the atom, okay? In atom, let me draw here in atom, okay? This is the atom, right? Atom have a nucleus. You remember that? Chapter 2? Atom has a nucleus. Then have a different level. First level, second level. Remember I said the building? Yeah. Electrons are located in specific level. Do we live between first floor and second floor? No, we live first, second or third floor, right? Exactly it is. Remember I said like a building. So electrons are located in specific different level. Okay? And they have a specific energy based on their location. So, and then electrons are here, that n equal to 1, this is n equal to 2, n equal to 3, so more n equal to 4. Right? Fourth level. And if you heat atom, for instance, we have a lab which is called a spectroscopy lab. It's going to be end of the semester. So when you energize the atom, when you heat the atom, the electron in the atom is jump to the higher level. So when you heat the atom, electron in here jumping to here, jumping to here, or jumping to here, right? Going to higher level. So here to here, or here to here, or here to here, right? Jumping to higher level. So as you go to a higher level, it's gaining energy. And when you stop keeping energy, when you stop heating, then electron will come back will come back to the lower level. So when you're going from lower to upper level, it's gaining energy. If you see a picture in here, they're gaining energy, and when it's coming back, they're losing, they're emitting energy. On the emission, they show a different color during the emission. So when you go, so look at that, when you're heating up, it goes jumping to the higher level, right? That makes sense, right? When do you play soccer or football? Mostly football, right? I grew up in soccer and cricket, you know. So let's go soccer, which is common everywhere, right? Around the globe. So when you're watching a soccer game, your striker making a goal, right? Almost in the goal bar, right? Almost in a goal, right? What do? You squish down yourself, or you jump up? Jump up, right? Yes. You're excited. When you're excited, you jump up, go into higher energy, not putting down yourself, right? So that is happening when you're excited, electron jumping from lower to higher level. And when your heat goes off, then coming back. The emitting energy, the emission look like a fireworks. You know fireworks, 4th of July? You do that, right? Where do you go? It's been a few years in Houston. I usually go to Galveston. Nice and they're pretty good fireworks, by the way. So that is called Bohr model, okay? Study through the chapter about the Bohr model in details. It's gonna be a lot of questions in quizzes or tests. And we can go the next chapter. Next part of this chapter is quantum numbers. Have you heard that these 4 quantum numbers before? Yes? Quantum number, there are 4 quantum numbers. What is this? What do you need this for? Camilla? So these 4 quantum numbers, like the Camilla lives in Texas, right? She lives in Texas. If I say she lives in Texas, it doesn't mean anything. She could be white, she could be African American, she could be South American, different nationality. If I say in Houston, oh, she lives in Houston, such a racist city. Oh no, actually it's not it's a diverse city. Okay, suppose she lives in Houston. Oh yeah, I got it. She lives in a very nice and diverse city, right? So I get more idea. When I talk about she's looking at me like, stop it or Haque.
That's okay. It's okay.
So when you keep talking about something more details, ended up we know everything about the Camilla, right? She, we say exactly she lives in Rabi Avenue, exactly 2020 Rabi Avenue. We say exactly where she lives, right? We know about details, her location, her house, her ethnicity, her, she goes to Dhanmondi, which school she's going to, we know everything, right? So that's called quantum numbers, like an address, like a details. I have an ID badge, right? So ID badge, it says only my name. It doesn't tell details about my name. I'm a faculty or I'm a student. It doesn't tell anything, but if you punch it, if you scan it, it tells you, oh, Dr. Haque, he's a faculty, he's a chemistry professor, right? It tells them. That means it details of something is telling us by quantum number. So quantum number reveal everything about electron in an atom with 4 different types. We know everything about the atom, how atoms look like, so let's go first one. Let's put the analogy in here. So first one is principal quantum number. It says how energetic the electron is. Is it, remember, you jump in or jump down, it tells everything. Second one, it tells you the angular, which tells you how the atom, how the orbital look like, because electron lives in an orbital. So how the orbital look like? Because depending on how orbital look like, it can tell you how where electrons are located. So shape of orbital is very important, because if you know the spherical, so electron live in that spherical shape. If you know like a p orbital, it's like a dumbbell shape, which is like a bow tie. So we know that yes, electron is living on that shape. You see? So that second thing tells you, angular quantum number tells you what kind of shape of orbital electrons are located. Third thing is magnetic quantum number, which is telling you the orientation. What is the orientation, negative or positive? Orientation of electron. Third, and the last thing is spin quantum number. Spin quantum number is kind of, it doesn't mean that electron always spinning, right? It doesn't, electron doesn't spin always. But electron are located in an atom. So each orbital, so orbital have different number of electron. Usually S2 orbital, 2 electron, P6, D10, F14. But each compartment of your orbital, 2 electrons can fit. So what is their spin? Ups or down? Like somebody is try to sleep. Somebody like to sleep in the right shoulder. Somebody like on the left shoulder, right? So which shoulder you live on? You sleep like that. So you can say one electron right shoulder, one sleep on the left shoulder. Like a spin. How they are staying. It's not they are spinning, jumping, not like that. Okay. Let's go in details. We'll be learning about their exactly how exactly they look like, how exactly they're energetic. Okay. The first one is principal quantum number. Okay, what is principal quantum number?
The smaller n is the lower energy.
The principal quantum number is the energy of an electron. So let's go principal quantum, which is n, principal quantum number. Okay, and it could be 1, could be 2, could be 3, could be 4, right? As you see, n equal to 1 means principal quantum number 1. N equal to 2 means principal quantum number 2. 3 means, n equal to 3 means third level. Okay, so first, second, third, fourth, right? If you look at the periodic table, so level 1, that means their first level, right? Level 2, second level. Level 3, third level, right? Period or level, right? And this is the group, not the group. When you go from top to bottom in the periodic table, it increasing the level. Top to bottom, increasing the level, right? And that is this period, top to bottom. That's called first period, second, third, fourth, and up to sixth. That's called principal quantum number. So if n equal to 0, n cannot be 0. I mean n equal to 1, 2. So n equal to 1 means lowest energy. 2 means higher. 3 means more higher. Keep increasing the energy based on n value. Okay? Then, so look at that. If n equal to 1, s orbital is small size. If second, then s is bigger. Third, it's getting bigger. You see? So these small size mean probability of locating electron is right in here. It get bigger in second level. Probability of locating electron or energy of electron is getting greater and keep getting bigger. And number of electron in each level is determined by their value n square. So first level, let's go n square, first level, only 1, right? Because 1 square equal to 1, right? The formula is n square. In the second level, n square equal to 2 square, right? Equal to 4. So second level could have 4 electron, 4 orbital. We're coming there, how it works. And third and fourth and so on. The second angular second quantum number is called angular momentum quantum number. So this quantum number is used by L. This lowercase l equal to 0 to n minus 1. 0 to n minus 1. So it starts from 0 until n minus 1. And then the formula is L equal to n minus 1. So 0 to n minus 1, actually formula is n minus 1. But it just starts from 0. So let's see that the value of n. If n equal to 1, what is the value of L?
0.
0, because put 0, 1 in here, is going to be 0, right? 0 to 0, 0. What if n equal to 2? What's the value of L? Put the 2 in here, 1. But actually, 0 to 1, you see? 0 to 1. That means 0 and 1. So you're going to start from 0. When we talk about L equal to 1, remember something. Sometimes students a lot of time ask questions that when you say L equal to 1, it means actually 0 in it. When it says L equal to 2, it means 0, 1 in it. Because the formula comes from 0 to n minus 1. Do not remember only n minus 1. Remember from 0 to n minus 1. So telling L equal to 2, that means 0 to 2. Okay, remember that part. And how about n equal to 3? What is the value for L? So 0, 1, 2. Okay? Anybody not clear, please? We have enough time, we can discuss, or after the class, please talk to me. And what if n equal to 4? 0, 1, 2, and 3. Yes? Even the value is all value 0 to n minus 1. Not only 0 and minus 1. 0 to all on integers. 0, 1, 2, and 3. So that's the value of n in the standard, right? So what does it tell us, this L value? This L value tells us the shape of orbital. The shape of orbital. How? The formula is, if, let me write it in here. So L equal to 0, 1, 2, 3, 4. So if L equal to this value, it's talking about if it's 0, S orbital. 1, that will be p orbital, and if L equal to 2, that's called d orbital. L equal to 3, f orbital. See? S, P, D, F. So if I have the L value is 2, that means I have a d orbital in there. That means, look at the something. First level in the periodic table, I have s orbital. Only. I have only s orbital because I have L value only 0. So only permitted orbital would be s orbital. How about the next one? Which orbitals are possible stay in the second level? S and P. Exactly. So which orbitals are allowed stay in the third level? S, P, D. Wonderful. S, P, and D. Right? How about the fourth level? Look at the fourth level. S, P, D. That's all? F. Yes. That is, let me draw it here too, to make it more clear. So first level S, second is SP, third is SP, D, and fourth is SP, D, and F. Right? That's how they are permitted orbitals in different level of atom. And also make sure you try to relate with the periodic table. That will be easier. So first level, you keep moving the period, keep increasing the level. You will relate that in the next chapter too. when we're writing electronic configuration, that will be more easier to understand what we talked today. And then you can see how they look like. As like a spherical, double, like a bow tie. This is like d orbital, complicated. This is like a f orbital, more complicated. Okay? You don't need to know how to draw them. Just try to imagine them. How they are locating in different level of atom. The third quantum number is magnetic quantum number. Remember the word orientation. That tells you the orientation of electron in the orbital. Right? So remember, I had the Camilla's details. She lives in Texas. She is from South America. She's exactly this neighborhood she lives. We talk about all details to know someone. How electron is look like, how energy, how the shape, which shape it is in located, and then what is the orientation in details. So how it goes? It goes the formula of ml, both are lowercase m and subscript l, ml. You don't need to put bracket, it's just subscript l. So ml. This ml is called magnetic quantum number. The formula is negative L to 0 to positive L. You see what did I write? Not all the way negative L to positive L. Negative L to positive L. So this angular quantum number dictated by principal quantum number. And this magnetic quantum number is dictated by angular quantum number. Because the value of ml depending on the lowercase l. Lowercase l means angular quantum number. So that means if I have a 0, L value is 0, right? For the first level. For the first only s orbital, because L equals 0. Tell me what is the magnetic quantum number in the first level? Isn't it? Yes, it is, right?
Yeah.
So negative 0, 2 0, 2 positive 0. That does mean actually 0. Negative 0, positive 0 have no differences. Actually, it is actually 0. Right? So I put it down so make sure you have no confusion. For the second one, L equal to 0 and 1. The formula is negative to positive. That means I have a 1 first, right? Negative 1, 0, positive 1, isn't it? Yes? And let's go, one more thing we need to know is number of orbital. Number of orbital formula is 2L plus 1. So 2L plus 1 is the formula to calculate number of orbital. So 2L plus 1 is L value equal to 0 in here. So 0 plus 1 equal to 1 orbital. So the first level have a, you can make it, let me put a line for here. That will be easier. Okay. So first level have a only 1 orbital. Because 12 plus 1 means 2 times 0 plus 1, which is only single orbital. The first level, right? We already saw that. So theoretically also proven that's only 1 orbital. How about you have N equal to 2, L equal to 1. If L equal to 1, then negative 1, 0, positive 1. So if you put 1 in here, there will be number of orbital will be 3. See? And you can see that 3 orbital. 1, 2, 3. 3 orbital, yes. You can see that too, right? So based on the orientation, you can see how many orbital you have. Also, you can get from the formula 12 plus 1, that gives you 3 orbital. And then If n equal to 3, then STD is 0, 1, 2. Then what is the value for magnetic quantum number? Yes, negative 2, speak up. Then what? Negative 1?
0.
0. Then what?
+1, 2.
Plus 2, right? Then calculate the how many orbitals is possible. You can see from here, 1, 2, 3, 4, 5, 5, right? Also look at that, 2 times 2 plus 1. This also shows that this is 5 electrons, 5 orbital possible, right? 5 orbital. If you want to see a more make light, right? So that's right. How about the 4? If 4, then SPDF until 3. So negative 3. Negative 3, yes, go ahead.
Yeah, 1, 0.
Right? How many orbital possible? How many orbital in the 4th level? 7. You can see 7 in here. You can see the 12 plus 1. Right? Thank you. Okay. So the last one is spin quantum number. Okay, I have something here you can see. So S orbital can have 2 electrons, P can have 6 electrons, and D can have D can have 10 electrons, F 14 electrons. Okay, we'll see that in next chapter. Okay. The last one is spin quantum number. It doesn't mean that there is electron spinning. It means that each electron had one positive, one negative types of spinning. That means if I have orbital like this, or if I draw orbital compartment like this, each compartment have 2 electrons, one this way